Okay, everyone, we're going to talk a little bit about engineering notation rules during this session. First of all, what is engineering notation? You've probably heard about scientific notation. Scientific notation would be when we express a number as one number to the left of a decimal point, and then some more numbers to the right of a decimal point, and then times 10 to some sort of power. And let's just go ahead and pick a number now. We'll pick just randomly 19,243. Okay, that number in scientific notation is 1.9243 times 10 to the fourth power. Fourth power, I get that from my decimals, and if we double check that on the calculator, I can do 1 point. I have to switch over to regular 19243, enter. Okay, so if I then do that same number in scientific notation, you can see that or not, but I definitely do get 1.9243 times 10 to the fourth. But if I was going to write that in engineering notation, I would write 19,243 as 19.24 kilo something. So let's just say that it's volts, kilovolts. Okay, so there's some rules behind what I did there, and I think it's important to know what those rules are, because when we're doing our work, we want to follow those rules, but sometimes we don't always know what they are. So let's just list them out here. Number one, show 4 significant digits. Notice I chopped off the 3 up here in my 19,243. If that had been a 5 or above, it would have rounded. So there gets to our second rule. Round the fourth digit by looking at the fifth. Okay, so here I looked at the fifth digit, 4 and below. Just drop it. 5 and above, round up. Okay. Rule number 3, display numbers in powers of 3. Okay. So what do I mean by that? Well, that's what we did with the kilovolts. We took off decimal place of 3, and we said, okay, what we want to do here is we want to display it as a certain amount of numbers to the left. So what I do is I always display in powers of 10 to the 3, 10 to the 6, 10 to the 9. That would be kilo, giga, kilo, mega, giga. Or small numbers, 10 to the minus 3, 10 to the minus 6, 10 to the minus 9, 10 to the minus 12. And that would be milli, micro, nano, pico. Alright. Kind of running out of room here. So rule number 4, let's just start another page. Rule number 4, don't forget your units. You can't just have 19,243 something. We'll have 19.24 kilovolts. The rounding is important. Getting the numbers right, we'll talk about how to choose that in a second. Kilovolts, and then the volts part. Our units can be anything like henries, farads, ohms, amps, watts, volts, hertz, and items like that. There's even wild ones out there like Teslas, things like that. Coulombs, you may have heard of those in your AC and your DC. So we'll just do etc. 5, show 1, 2, or 3 numbers left of the decimal. Alright, so our numbers are going to look like, if we took 17,000, let's just 179,621 ohms. What are we going to do? We're going to go from the decimal point over to the left 3 so that I have 3 numbers to the left. I have my 5th place as a 2, so I'm just going to drop it. 179.6 what? Kilo, because kilo represents dropping 3 zeros, ohms. Okay, let's do another one. We're dealing with hertz. We're up into the millions, possibly the billions. Hertz. Okay, turn that one into 2.425. My 5th digit is a 1 megahertz. Okay, I'll just do one more. We'll go into the very small for this one. So let's say that we have a tiny amount of watts. And here I'm going to go to the left, to the right 3, but that's not far enough. I don't have any significant digits yet, so I'm going to go 3 more. I've gone 6 places. I'm going to either go 3 or 6 or 9. I never want to go 4 or 2 or 7. It's always multiples of 3. 3, 6, and that gives me 625.1 millis, micros, microwatts. Okay, so that's how you do engineering notation. And except for for a few instances, I'm going to want you to use engineering notation in the class.